Hello everyone, how's everybody doing? Hope you're doing better than me. Today we're going to have an exciting day. I'm going to start out by saying that I uploaded a book. Okay, for those who are interested, you can download it at ropehypothesis.com. It's a free book, okay, and it puts you up to speed, brings you up to speed on what this site is about. It talks about the rope hypothesis proposal, a new vision of the universe. And so, yeah, it's a new version that you may want to get acquainted with so that you know how this universe works, or at least have a different version of how this universe works. And for those of you who have a second language, we would like to make sure that you contact us at tokakaka. See if I can get this thing up here. I'm not sure why I'm having problems lately with some of these. Let's see if I can get this thing here. Oh, I erased it. That's what it was. Anyways, you contact us at tokakaka with K's, all K's, at hotmail.com, and we're going to send you a file that you can translate to your native language. Okay. Anyways, I've got some good news for you today. Some good and some bad news. Bad for me, really. The good news is that I found an antidote to the coronavirus. And it looks like this, you know. It's a jalapeno. And you put it in your mouth, you know, you chew on it. And when the first teardrop starts falling down your cheek, you're protected. And if you're like me, you eat like 10 or 15 of these per day, you know, the next morning you might have some surprises at the other end. Okay, so anyways, and the bad news is I'm not feeling good. That's bad news for me. I've got a little bit of a headache and I've been coughing a little bit, so 'tis the season to be sick. You know, this is a transition from winter to summer. Every 2 years or 3 years I get a cold or something. I hope it's nothing worse than that, okay? I hope you're feeling better than me. Anyways, let's get on with the subject matter today. We're going to start out a little bit with the coronavirus / extinction theory. Okay, we're going to address that, and then I'm going to go over waves and a prism and water, how light goes through a prism and through water. Okay, essentially that's it. We're going to be addressing those issues. I'll start with comments because several people made comments. I want to address those comments. Okay, here's the first one. Okay. Says, Bill's theory of extinction of humans is the disappearance of money, and yet he presents no evidence, zero evidence. The disappearance of money, no definition of what it is. Okay, so let's address that. First one regarding evidence. Okay, here it is. In science, we have no use for evidence. Evidence has to do with convincing people. It's what the prosecutor uses to persuade the jury to vote in his favor. Okay, so evidence is a hallmark of religion because it is in religion where they harp on belief. In science, we have no use for belief, and so therefore we have no use for evidence. You can believe whatever you want. What we do in science is we, especially as it relates to physics, what we do is we present a mechanism. Okay, so once you have a mechanism that you understand, that's the end of science. What continues is religion, your belief in whether the universe works that way or not. That's a separate issue. And so we have no use for evidence, okay? And money is any medium of exchange which has no intrinsic value. And when we talk about intrinsic, a lot of people get confused because they have this this notion of what intrinsic means that has to do with exchange value, okay? And that's not what we're talking about. We're talking about intrinsic, like I say there, bartering involves only tangibles which have intrinsic value, that it has some use as it is. you have no use for dollar bills. Okay, it's money, and the dollar bill itself has no use whatsoever. We give it money. In our brains we give it money, but we have no real use for it other than maybe as bathroom tissue. When it runs out, that's about it. I mean, we have no use for dollar bills. So as far as intrinsic, dollar bill has no intrinsic value. It only has value in your mind. Okay, I'm talking about tangibles which you can use for something. Okay, that's bartering. Okay, it's got to be a tangible that can be used for something. And so, yeah, here are a few words of religion, just to put his comment in the right perspective. It says these are the 4-letter words of religion. Okay, and yeah, we don't talk about something that is accurate, for example. Okay, we don't care about accurate or precision. You'll see precise there in the second column at the bottom. We don't agree in science, okay? We don't vote, okay, for theories. That's religion. And we don't agree, for example, the definitions. We fight for them. We defend them with sword and shield, okay, or maybe get in the ring and fight for them. That's the way it works in science. We do not agree and say, well, let's agree on your definition. No, you got to fight for it. If there's something wrong with the definition, you got to try to throw it down. You got to point what the shortcomings of that definition are and what they will cause if you use it. Okay, that's important. We don't rely on authority. A lot of people say, well, all the scientists on Earth cannot be wrong. Well, we don't care about that, because if they're all wrong, then Mother Nature calls them wrong. If you say space-time is something that's out there, if you say that particles can be at 2 places at once, and that's what all the scientists on Earth believe because they believe in quantum and relativity, it doesn't make it so. Okay, so we don't care how many people. Again, we don't vote for theories. Okay, and we don't do calculation. We don't use math at all. Why? Because science is not about describing. You see the word describe there? No, science is about explaining. And you can't explain with math. Math, an equation is only a description. Okay? So no use for calculations, no use for equations. Okay? And people say, well, what are you saying? This is a different site. Okay? So if you just came here for the first time, and you came with all these ideas that you got from high school and college, where science is about predicting and observing and describing equations. None of that has any value here. All that belongs to religion as far as we're concerned. Okay? Why? Because science is about explaining. In physics, we have to explain mechanisms. Once you understand mechanisms, science is over. What continues from there on is religion, your belief, and whether you proved it to yourself, whether you verified something in your own personal opinion. All that stuff has to do with biases, with subjectivity. Okay, and technology has nothing to do with science. Okay, so whether something is useful, the letter U there, or something works, the letter W there, okay, useful or works has nothing to do with science. We don't care if it works. Some people say, well, you wouldn't have a computer if quantum were wrong. They come up with these nonsense notions. And no, a computer does not prove that a particle can be at 2 places at once. It's the theory that's ridiculous and irrational that quantum proposes. And you have people like Richard Feynman, Nobel Prize, 1965. You have people like, Susskind, Leo Susskind from Stanford University, so-called physicist, mathematical physicist, mathematician. And all these people tell you in your face that they don't understand their own theories. And people don't understand that. They say, no, of course you understand your theories, because otherwise we wouldn't have a computer, we wouldn't have GPS. No, one thing has nothing to do with the other. GPS does not confirm that relativity is correct or that Einstein was correct. GPS only was developed by trial and error, okay? And until people understand that, they won't understand anything. The fact that GPS works does not mean that there is a physical entity out there called space-time that is warped and compels the photons to swerve. Okay, that's the issue. The issue is the theory has nothing to do with the technology. Science is about theories, not about useful stuff that work. Okay, so let's get those things right. That's why a lot of people find this site a little hard to swallow because they come out of college and high school believing in the notion of mathematical physics, of science of mathematical physics. And you have to understand how we got here. You know, we got here that way because mathematicians developed science, so-called science, used to be called natural philosophy. They developed the long equations. They thought they were going to figure out how this universe works by doing experiments and measuring and coming up with equations. All that has to do with descriptions. Has nothing to do with explaining how Mother Nature does her daily work, you know, gravity, light, magnetism, etc. Okay, so let's keep that in mind. This side is about how the universe works. We don't care about your math. We don't care about your calculations, your measurements, none of that. We can erase all that from the history books. It wouldn't matter at all. We need to figure out how Mother Nature does gravity. And for that, there's only one way, and that's figuring out what invisible entities she uses as mediators, period. So what we have to do is figure out what she's using. That's it. You know, what entity she's using to do gravity, etc. Okay, so what's the issue here? We have also in relation to what this fellow said, you know, what is value? And do we have any use for value? See what I call Disneyland economists. Here you have a couple of them, very famous guys, all of them. You probably heard of them. These are all Disneyland economists. They have no place in real economics. Okay, so if you studied these guys in college or heard about them or you know, look them up, all these people talk about value. And, you know, Mother Nature has no use for value. The only thing Mother Nature cares about is the natural economy. Okay, and that's different than all this artificial economy that all these guys dealt with. Natural economy has to do one thing and one thing only, and that's food. Okay, and there's a simple test that you can run. I call it the Bill Gates dog test. Okay. You go to the bank, okay, listen carefully now. You go to the bank and you borrow $1 million, okay? And I'm sure they'll give it to you, no problem. I mean, you're just going to borrow it for 15 minutes. They shouldn't have any objection, okay? And then you go in there and you get a hot dog, okay? Okay, little hot dog. So you get $1 million, you get a hot dog, and what do you do with them? Well, you bring your dog and you ask them, and you put them separate about 1 meter apart and find out which one the dog grabs. Does he grab the $1 million or does he grab the hot dog? So for all you people who are floating out there in space, your dog will bring you down to earth real quick on what value really is, okay? And you can do it with a cat. Not Schrodinger's cat, he's half dead, but you know, this is how you prove to yourself what has value. Okay. Right now we have so much artificial stuff. We're bombarded with so much information that we lose track of that which truly has value, which is food. It's the only thing that really has food. And you know, if tomorrow the stock market crashes completely, money is no more. This fella here, you know, Bill Gates, is worth as much as Bill Gates. Okay. All his stock is just a bunch of paper that he can throw away. It's worthless junk. And so you got to keep that in mind that, you know, it's all contextual. His stock is worth it only if we give it value. Once the whole thing falls apart, you know, all that has no value whatsoever. Now, some people will say, well, Bill, if you know, they have these theories about the so-called Illuminati or rich people in general, that they've got presidents and so on. They have all these secret places where they're going to hide together with their servants, when the shit hits the fan, if it does, right? And so they have all these preparations there, and they're going to introduce a new world order, a new way of doing things in which everybody's a slave and they're going to be the masters. Well, I don't know about that, Imagine the Queen of England, okay? Queen Liz. And, when things get really rough, she goes into her dungeon with her servants, okay? And they're all protected down there, I guess, while the whole world collapses around them. Is that possible? Or is she doing the right thing there? Imagine now her servants. They served her for many years, maybe, and now they go down there. They have no reason to respect her anymore, to bow down to the queen, because what's she going to bribe them with? Money? I mean, the only thing at that point that has any value is food. And, the servant, in fact, can get it himself, and he doesn't need to bring it to the queen. So the queen right there, she's in worse shape than she thinks. I mean, maybe she becomes the servant for all we know. I mean, how's she going to compel her servants to serve her after the whole thing collapses? So I don't know about this new world order. I mean, I think more than likely what's going to happen to Liz is something like this. Maybe her cook who hates her and just follows orders because she's the boss. Things might switch around 180 degrees after the collapse. And good old Liz might end up, trolling around in her own backyard. Maybe she's going to end up being food, maybe, for all we know. So, you got to think about these things, whether it's really possible for these so-called Illuminati to go down in a basement and have their servants, vouch for them and keep serving them. I'm not sure you're going to compel them. How are you going to compel the army? How are you going to compel anyone without money? Once money's gone, there is no chain of command. Every man's for himself. So you got to think about these things, Some people say, well, I'm going to rush to the mountains, or maybe they're already in the mountains. One fellow says that he's self-sufficient. A lot of these people, they think they're, when the whole thing collapses, they say, well, I'm just going to go with my gun or my bow and arrow and going to hunt buffalo or whatever, out there or bears in the forest or in the mountains. And they don't realize that there's going to be a lot of competition. A lot of people are going to think of the same thing. They're going to go out there and hunt whatever animal is alive, and they're going to kill that animal, and suddenly all the animals are wiped out, just like they were in the Cretaceous. They say that the only thing that more or less survived was anything smaller than a cat. Why? Because, T-Rex was hungry and he'd grab anything that he could find. So, that was more or less big, bigger than a potato chip, So, yeah, I mean, there's going to be competition, that's for one. And if you've got a little garden, you say, well, I'm just going to, if the whole thing collapses, I'm going to be self-sufficient. What I'm going to do is just grow my own potatoes or wheat or whatever. Well, you're going to be joined by a lot of people. They see wheat in your house, you better have some protection. And that's what a lot of people don't understand. There's people who told me, oh, the Amish are going to survive, see, because they're self-sufficient, they grow their own stuff, etc., etc. Yeah, but what nobody seems to understand is that the only issue after the whole thing collapses is security. There's going to be no 911. There's going to be no defense budget, okay? And so the issue is you're on your own, and when you have someone come into your territory, you better know how to defend yourself. You're going to have to defend yourself against a lot of people out there, okay? So keep that in mind. The only issue is defense. That's the number one issue. Without defense, you have nothing. Whether you are self-sufficient growing crops or whether you're self-sufficient hunting out there. No, if you're self, for sure you're going to die. You got to do this with a group, okay, if you're going to survive. You don't have a group, for sure you're going to die. Okay. The other thing is, by the way, also if you're self-sufficient, one of the things that you're going to run into as a problem is when you get sick. Right now, I had an operation, what was it, in January, and it was nice because they put you to sleep. You don't know anything. When you wake up, you're done. They fixed you up, whatever operation you had. Later on, it's going to be, with a knife, a little bit of whiskey, and bite the hanky. That's how it's going to be. And that's if you have someone else with you. If you're all alone, forget it. You're going to have big problems. Even a toothache's going to kill you. So yeah, keep in mind all these things. Defense and health are number one, before food even. Okay, another person made a comment. He said, regarding extinction, he said, you are thinking linearly and not cyclically. Yes, food production goes up and down in cycles. Okay, the great thing about humanity is we have a strong drive to take care of our self-interest. Well, let's address that. First of all, all animals are self-interested. They take care of themselves. Okay, so every living animal, I would say, is self-interested. Okay, so you said nothing. The other one is, we had a flow of the mode of production of how we ran our economics in the last 200,000 years. We were hunter-gatherers for most of that time. Okay, and I have a little chart here to show it. Okay, it gives you an idea. Okay, it's one of my papers that I published, and you can see that we were hunter-gatherers for at least over 100,000 years for sure. And then we went about 10,000 years ago. These are round numbers. Okay, 10,000 years ago we went into farming. Okay, and from there we went into manufacturing about 200, 300 years ago in the 18th century, more or less. That's when we started, okay, the process. We're still in that process of converting from farmers into manufacturing in many countries, and from manufacturing into the last category, which is services, most of which is unemployment. Okay, services is an unemployment line item, okay? And here you can see the breakdown for the entire planet, okay? Let me get back in here. Okay, here you see the breakdown. Now this is one site that I saw. You'll see similar sites everywhere. You can go to the CIA site. You can go to the World Facts, and you'll see something similar to this. So they're all more or less the same. This is the breakdown from 2007 to 2017. And what you see there is that what's growing is services at the expense of what? Of agriculture and manufacturing. And this is global, okay? So what you're seeing there. Okay, and that trend was not only predictable, and it's inevitable, and it'll continue in that direction. As smart as we are as humans, we can't stop that. We have no power to stop this. People say, oh, we can do anything. No, we can't. We can't stop that. Okay, this is predictable, deterministic, nothing that we can do about it. And what's causing this is efficiency. We're becoming more and more efficient in agriculture. We're becoming more and more efficient in manufacturing. And so the new workers that come into the world, the new generations, they have no other choice but to go into services. And again, like I said the other day, most of services is unemployment. It's masked unemployment. Okay, finance, 20% of the U.S. economy. What is that? It's promises, insurance, credit, banking. It's all promise. It's nothing. Someone sings. And you say, well, I got value because I got something I liked. So here's the audience. They're listening to them. They're paying for it. What did anybody in that transaction get? Well, I got value. See, I heard a nice music that made me feel good one day, 5 minutes or whatever. And the other person got, a bigger number in his or her bank account. Okay. Suddenly, instead of $100, that person has $200 or whatever. Okay. So what did we all get? Well, we got nothing. That's what it is. We got value, as Disneyland economists would say, and they talk about value. And yeah, value is nothing. Okay, that's the way I see it. You don't have to agree, but just so you know where I'm coming from on that issue. And regarding that last statement, where was it? I think it's this one. Yeah, let me put that back up here. It says that food comes in cycles, okay? And so here's the population curve for the last 2,000 years, more or less, okay? And I put the food curve there. You know, the only way we can sustain people is if everybody's got a plate of soup, you know, every day. So you have to produce food for ever more population. And so it is not cyclical. It is linear in the sense that it's growing in proportion to the population. See, food is one of those strange commodities that you can't have too much of and you can't have too little of. Okay? Food is a Goldilocks commodity. It's got to be just right. You have to have the right amount of food per day, per people, per person. Okay? So if we got 8 billion people on the planet, you have to have food somehow on your table for 8 billion people. It's just that simple. And so if the population is growing, then food is growing, has to be growing in order to sustain that population. So no, not only are we not going back to manufacturing and to agriculture or, God forbid, to hunter-gathering, right? But likewise, we're not going to be producing less and less food, like in a cycle, a downward cycle, unless the population collapses. Then yes, you're going to produce less food because you don't need as much food for fewer people. But as long as the population keeps increasing at an ever slower rate as it is now, you're going to need more food. And so no, it's not cyclical in that sense. In the long term, it's always going up, 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 up in proportion to the population. Okay, let's get to a couple things that I wanted to mention, and that's what science is about. Science is, especially as it relates to physics, okay, let's get this right, is about mechanisms. You got to tell someone what the mechanism is that Mother Nature uses to do her invisible work. We know all the visible stuff. We know how a pulley works. We know how the window broke, you know, a brick went through the window. We know how a seesaw works. You know, one goes up, the other one down because there's, you know, one guy pushing up and the other one down and so on. We know all this stuff because everything is touchable, everything is observable, seeable, okay? What about the invisible stuff? What about magnetism? How does a magnet work? Now that's magic, right? Because we can't see or touch the mediator, okay? So what you have to explain is the mechanism that Mother Nature could be using. And, you know, you might have a different mechanism. I can only tell you what my mechanism, my proposals are, right? The mechanisms I propose. And here's the one for light. I just want you to understand it, okay? Here you have two atoms. They're quantum jumping. Okay, they're expanding and contracting. By doing so, they they torque a rope that's between them. Okay, and that rope is what we're going to call light. That's the mediator for light. We're putting a rope there between two atoms, right? Binds the two atoms physically, and it expands and the atoms expand and contract. And what it does is, by doing so, they torque the rope, and that torsion is what we call light. Okay. Too difficult, or do you think you understand it? Okay, here's magnetism. Okay, we have two magnets, and you can see the mechanism. We're saying that you have these threads that come out of the atoms that form the magnets, and these threads are swinging around. Repulsion, the threads hit each other and push each other away. And in the case of traction, they both go in the same direction. Okay, and so they kind of latch onto each other, and that's how they pull the other magnet. So the issue here is whether you understand the mechanism that I'm proposing. I'm saying, you know, repulsion, the threads hit against each other, and attraction, the threads swing around in the same direction, both clockwise in this case, and by doing so, they latch onto each other and attract the other magnet. Okay, that's the mechanism I'm proposing. Gravity, okay, here's gravity, okay. You have a box falling to Earth, okay, and you have different angles the closer it is to Earth. And here you see it. As it comes down, okay, more and more threads fan out, ropes fan out. Okay, the ropes fan out, and you have more and more ropes pulling the closer the box is to Earth, because every atom of the Earth is tied to every atom of that box. Okay, that's the theory. That's the mechanism that's being proposed. You can see that there's different amount of ropes when the box is closer to the Earth, and that's what we call weight. Okay, weight is a location-specific parameter. Okay, and here's a static version of that. Also, you can see what I'm proposing there. Essentially, okay, when two objects are far apart, the ropes come together. They form a single coaxial, so to speak, so gravity is weak. And when the two objects come closer and closer together, the ropes fan out because all atoms are interconnected. Okay, and even closer, like in the case of the last case there, the ropes are completely wide open. The two objects clash. Okay, and this does explain Newton's equation. Newton's famous gravitation equation, especially that factor mass 1, mass 2 over distance squared. The longer the distance, the lower the force. And shorter the distance, the greater the force. And there you see it in an illustrated. Okay, so the question is whether you understand it. Okay. Okay, let's move on. We've got, I think, another one here. Yeah, electricity. What is electricity? Okay, here it is. Okay. You have the standard version of electricity, which is the flow of electron beads from atom to atom. The electron is treated as a little bead that somehow orbits or is somewhere around the nucleus. The quantum mechanics version gets rid of the atom altogether and just sends beads across. Doesn't need any atoms whatsoever. That's the quantum version. And then the rope version is serpentine that twirls in place. Okay. All the atoms are interconnected. They're physically meshed into each other. They're blended into each other. The threads that form the electron shell are blended, and the whole thing twirls like a drill bit. And here you see the difference in a different format so that you can see. The quantum version, official version, is gun shooting bullets. That's how you make holes. And rope model is a drill bit twirling in place, and that's how we make holes. Okay, and this is a way of comparing mechanisms, especially when you're doing the slit experiment. Okay. So the question people have is, Bill, I don't see any ropes. Can't touch any ropes. What are you talking about? I don't see you touch them, and so I don't believe in your ropes. Irrelevant. Irrelevant. Right now we're concerned about one thing and one thing only. Do you understand the mechanism? Did you understand the mechanism? You can revise this later on if you want. Do you understand the mechanism of light? What I'm proposing for light. Do you understand the mechanism of magnetism? Physically, how one magnet attracts another. Do you understand the mechanism of gravity? How the ropes fan out as a box or whatever falls to Earth. It could be an astronaut or someone falling from an airplane. Do you understand the mechanism of electricity? Do you understand the mechanism? Do you visualize it? Have you grasped that first? And if the answer is yes, if the answer is no, well, then you need to have clarification on that, because if the mechanism is incorrect, if it doesn't explain what happens out there, there's no need to answer any other question. Okay, because if the mechanism fails, there's no need to continue with any kind of questions. The only reason a person would ask more questions is if he concedes that, yeah, that mechanism does work for gravity, for magnetism. Have I mimicked the mechanisms? And if the answer is yes, then I get to ask the next question first. Okay? And that question is, can quantum mechanics do the same thing? Can it rationally explain those invisible mechanisms with their particles? Because I don't want you going back to quantum mechanics if I can't answer a question, for example. We got to make sure we get rid of quantum mechanics, the explanations, the physical interpretations of quantum mechanics first. And so let's get rid of that first. If quantum mechanics can explain the mechanism, fine. But for sure they can't. You know, it's all irrational explanations coming out of quantum mechanics. And that's why all these guys like Richard Feynman and Leo Susskind, you know, they say they don't even understand their own theories and they'll never understand it. We just do science, which is a process, whatever that is, you know, and we just investigate and never find, we'll never figure it out. That's what they tell you. And so let's get that clear. First question is, do you understand the mechanism? And if you do, the second question is, can quantum explain the same mechanisms with particles, with discrete particles or waves? Waves should not be in there because quantum uses the wave as a crutch. You know, when they can't explain it with particles, they say, oh, well, let me explain the Slit Experiment or Compton's, the Compton effect with waves or whatever, you know, or anyway, they twist it around. And yeah, no, you have to, if you're going to explain polarization, for example, you can't go back to waves and say, well, now I'm going to turn my particle into a wave to explain this. That's a cop-out. That means they're using things, they're using an ad hoc thing, mediator, to do their different explanations. And again, yeah, anybody can do, explain anything that way when you just turn, a rock into a sponge or whatever. You know, say, well, here I'm going to explain with a sponge, and here I need the rock, and over there I need a stick. You know, what is this? You just change things as you need them. You know, that means they don't have an explanation. That's it. And that's why they claim that they don't understand. They can't give you a physical interpretation. Okay, here are more comments that were made along these lines having to do with light and some of the mechanisms. Okay, here's the first comment. Said, how does the rope model attack Bell's theorem, the quantum Venn diagram paradox? Okay, and that's related specifically to polarization. I'm not going to go over that here, but I'll just say that there is an answer, and you can find it in the book, The Rope Hypothesis. If you can download it over there for free, ropehypothesis.com, and if you go to pages 130 to 133, it's titled Extra Credit Polarization. You'll get an idea of how a third polarizer inserted between two reestablishes the beam of light partially. Okay. And incidentally, I just want to mention that, quantum doesn't have an explanation for this either. What they do is, again, what they try to do is they turn their particles into waves, okay? And you say, okay, so we have a wave. Well, not really. What you're looking at over there, those arrows, those are not engine arrows, okay? Those are vectors. And what they've done in mathematics is they did a little cartoon. That's what you're staring at. And it's a cartoon because what you're looking at, those arrows are really vectors. What is a vector? Vector has magnitude and direction. That's why the vectors are pointing up or sideways. And what they do, they put all these vectors there, one side beside the other, and all it's got is just a magnitude, okay, and they're pointing. And they turn this into something that's movable, and you think you're looking at a wave, so-called wave. A wave of what? A wave of vectors. What is a vector? A number, a value. That's all it is. It's just a quantity. And what you're looking at is quantities that are moving. You're looking at number 5s and 6s and 7s that are moving in front of your eyes. That's what you're staring at. And that's what they call a wave. So be aware of do not be fooled when you look at this and think that you're looking at a physical entity. You're not. What you're looking at is a bunch of numbers that these guys have going from A to B, okay? And that's how they try to explain some of these things when actually they haven't given a physical interpretation because they don't have anything physical in front of your eyes. But you think you have something physical because you see something flowing in front of your eyes and you say, oh yeah, it's the wave. No, there is no such thing as a wave. There is no such thing as a field. Okay? Anyone using the word field is a religious fanatic. There is no physical object called field. There is no physical object called wave. Wave and field are both dynamic concepts. You can't move concepts in physics. Okay, you can do it in religion at your Sunday school, not in physics. Okay, you can't say you're going to move information, you're going to transfer energy, you're going to warp time. Those are, that language is for mathemagics. Those people do magic all the time. Okay, here's another fella, and he asks a question, and goes something like this: why can't we see the ropes? Famous see touch, connecting each atom of Earth to other planets and galaxies. I'm asking this question because quantity of ropes that form magnet is very less than the quantity present between Earth and other planets. Okay, so he has this inquiry, this doubt, this thing that's going on in his mind. Well, the first issue, people have a hard time understanding this. Today we don't have a definition of the word object from the mathematical world, mathematical physics, mathematics. There is no definition of the word object because mathematical physics doesn't deal with objects. Mathematical physics only is interested in equations, in numbers, in describing. So they don't have explanations, they don't have mechanisms. That's why they can't answer qualitative type of questions. People are not familiar with that issue. It's a very important issue because every time someone goes out there, a layman, he wants to know how this universe works. So he's not going to ask you, give me the equation for this or this or that. What is Einstein's field equation? What is Schrodinger's equation? No, they don't ask those type of questions. People ask, how does this work? And the other guy answers with a description involving equations. And this guy says, oh, okay, and just goes away because he didn't understand squat. And and that's the issue. You'll never find a physical interpretation, a qualitative physical interpretation to a mechanism, to an invisible mechanism, such as gravity and magnetism. You won't find it. What you'll find is mathematical description. They'll give you a lot of wordage and verbiage there, and if you understood, fine. Otherwise, they'll tell you, well, you should study math at the college level, and then you'll understand. And then you'll understand the same thing as them. They won't be able to, if they can't explain it, you would have lost your time going to college trying to learn the same nonsense that they learned because all they can do is describe. So we're back to square one. They have no explanations. Okay, and so what's the issue with the ropes? Well, the issue with the ropes is that we start with a definition. And the word object is defined as that which has shape. So there is no provision for see or touch or smell or hearing or taste. You can't say, why can't I taste the rope? Why can't I smell the rope? Why can't I hear the rope? No, because that's not the definition of what an object is. An object is that which has shape, and a rope does have shape. Do you see something with shape here? That's a rope, okay? So ropes have shape, okay? So we met the condition of the definition. The definition is that you have to mediate Mother Nature's secret agents, You have to mediate them with object. You have to have a physical mediator. What is physical? What is an object? What is a mediator? It's that which has shape, not that which you can touch, not that which you can see. Not every object is seeable. You can't see the air, for example, and not every object is touchable. And until you grasp that really in your head, these questions are worthless, because people have to understand the definition of the word object, of the mediator that Mother Nature uses is not touch or see. The criterion is shape. Okay, it's got to have, a couple guys gave me a different version. Says, how about contour? How about, what was it? I can't remember the other words now. It's something like perimeter. I can't remember the words. Anyways, you're referring just to the outline, okay? And right now I have no counter-argument to that. I think they're all synonyms, but maybe someone smarter than me will figure it out. Okay, right now I'm accepting all those because, shape, contour, perimeter, all these referring to the outline of an object. Okay, as long as it's got that, and contrast was another one I proposed. There's got to be contrast. you know, because otherwise, you know, you don't have an object, you have an infinite object which is irrational. So, you know, I think all those are synonyms. Right now, I have no counter argument to that, okay? So, again, if someone's smarter than me, can figure it out. Anyways, these are types of irrational questions that people ask, okay? Let me put it over here, read them out real quick, okay? And the first thing that you have to note that you can't ask a question of purpose and reasons, right, in the context of physics. Physics deals with causes and mechanisms, okay? Let's get this right, okay? Physics deals with causes and mechanisms. Philosophy deals with reasons and purposes, okay? So when someone asks questions like you see some of those there at the bottom from A to I, why is there something rather than nothing? It's an irrational question. What you're asking already is saying, oh, did God make this? What was his purpose for making this? Why is there something? Well, I don't know. God had a headache. I don't know. Maybe he caught the coronavirus and decided to make something instead of nothing. I mean, you're asking a question of purpose and reasons in the context of physical causes and mechanisms. And people don't always understand. Why is the speed of light 300,000 kilometers per second? Well, I guess I could put there God, Mother Nature, Father Universe, and the devil, you know, wished it to be so. That's the answer to those questions. Why does time seem to flow in only one direction? Well, time doesn't flow. Time is a concept. So you can't say that time flows in any direction. There is no such thing as time. Okay, and so you can't use that word as a physical object and say, how does time flow like a river? There is no physical object called time. Okay, you got to talk about the things that move. You can say a lion moves, and you clock them. That's different than saying time flows, and that's not time that's flowing. It's a lion that's flowing, or a river, or whatever. Why is gravity so weird? Well, weird is an opinion, so we don't care about that. How did the universe begin? Well, that's irrational. You can't convert something into nothing or nothing into something. Unless you know the mechanism and you can explain the mechanism, that's an irrational question. What is the vacuum made out of? Vacuum is nothing. It's a synonym of zip, of nothing, zero, emptiness, whatever you want to call it. Okay, there are different words for that, synonyms. And so if the vacuum is nothing, you can't say, what is it made of? Is it made of something? That's a contradiction because nothing is the opposite of something. You can't say, what is nothing made of? Okay, you just got to define the word, and we define vacuum as that which has no shape. If something is that which has shape, nothing is that which has no shape. They are antonyms. Now we can use them consistently in a presentation, in a dissertation, okay? What's outside of infinite space? I don't know, more infinity? What is an elementary fundamental entity made of? Well, if it's elementary and fundamental, means that it's not, by definition, it's not made of anything. So you can't say, well, what is that made of? Okay, it's an irrational question. People don't always understand. What does a black hole look like? Well, zero-dimensional nothing doesn't look like anything, you know. And so they put a picture of a black hole, and people say, oh, the first black hole. No, you can't take a picture of a black hole because it's zero-dimensional. You know, and that was proven mathematically by Mr. Chandrasekhar, who got a Nobel Prize for proving that black hole is zero-dimensional. And people are not always aware of that, you know, it's been already settled. Black hole is zero-dimensional. Zero-dimensional means no size, no volume. I don't know what that looks like. You tell me. It looks like pretty much like nothing. That's what it looks like. So until people get these things there, you know, they keep asking these irrational questions because they don't understand where the contradiction is. And the contradiction is in language specifically, but also in, you know, in how these things are interpreted. Okay, today I want to talk specifically about this individual who has a couple videos online, and he misleads a lot of people. You can see there he's got these 560,000 hits. Okay, and he's from Fermilab, and this bozo known as Don Lincoln, he talks nonsense. And I want to expose this guy, and I think we should ridicule these people. First, because they make a lot of money on at your expense. Fermilab is maintained by the U.S. government. And so, you know, taxpayer money, that's what pays for this fellow to talk nonsense. And that's why I like to ridicule them. And I want these people out of science. They're not scientists. They're religious fanatics. And they have no explanations for things, something simple as light. Okay. And that's what I want to expose today. Okay. So here is a summary of why this fellow talks nonsense. Okay. And I'm going to go through each one of these. Okay. Let me put this here to the side, okay, and we'll go step by step here. First of all, this individual, he invokes what is it, Niels Bohr and Ernst Rutherford's planetary model of the atom. That's the model that they use in quantum mechanics to this day. They use it at CERN, the Large Hadron Collider. They use it at SLAC, the Stanford Linear Accelerator, and also at Fermilab. All these places they use the planetary model of the atom. And here it is. This is from their site, by the way. I'm not putting words in their mouth here because this is the atom they show. Okay, let me show you here. Here you see it. That's the atom. That's the atom they're going to use. Okay, what is it? A bunch of beads. Those, by the way, are not wires. Those ellipses there, those are supposedly the trajectories, you know, the contrails, if you will, of the electron bead as it goes around the atom. So they always draw them because if you take them out, you wouldn't understand the picture if they take those wires out of there. So they leave the wires in there and you think you're looking at an atom. Okay, so this is the atom that Fermilab's going to use, this fellow's going to use, okay? So there we have our first problem. Okay, what other problems do we have? Well, the second one is orbiting electron bead moves in transverse waves. You know, one of the reasons they never illustrate these things is because they can't. And I'll show that in a second here. You cannot illustrate imagine a prism, okay? It's got all these atoms that form the prism. And you have within each atom, you have all these electron beads that are going around in every direction, right? That's what quantum mechanics proposes. And these guys are saying, you know, that all those electrons that are going around their atoms, they're not coming out of the atoms. There's no ionization and there is no electricity. All we have is just a solid there, you know, prism, you know, and light comes in there. And so how do they explain the slowing down of light through this prism, which suddenly they claim that slows light down? Well, the way they explain it is say, well, all these electrons form a wave, and the wave is slower than the incoming wave of light, and so it slows down the wave of light. That's their explanation. So let's see if we can visualize first, okay, before we continue. See if we can visualize this electron wave, the waves of electrons, okay? I tried to illustrate this thing. You tell me if I succeeded, okay? Here it is, okay? I want you to tell me how all those atoms that form the prism, right? The electron beads that are going around the nucleus, how that turns into a Fermilab wave, which is how they're going to explain the slowing down of light. I mean, how does the guy on the left become the one on the right? How do you make a transverse wave that moves in one direction and slows the wave of light? Remember, number one is the wave of the electron wave. Number two is the red one is supposedly the one of light. And then the third one is the summation of these two. Okay, that's their argument. This is out of their website. Okay, and the question is, how does the electron beads of the prism equal number one, which is a very slow moving wave. Okay, as you can see, it's moving very slowly. I mean, you cannot even conceptualize it. You cannot visualize what they're saying, and that's why they never draw it. They never illustrate this stuff because it's unillustratable. You cannot illustrate this, okay? But I don't plan to hold my breath, but it's up to them. They have to illustrate it. I did my best. That's the way I see it. I cannot illustrate what they're saying, but maybe they're smarter than me. I don't know. Okay, light is a waving electric field. This is what they say, okay? But field is a bunch of vectors, magnitude and direction. And here's proof. Those people who like proof and evidence, here we have proof and evidence, okay? We go to the definition. We find, at least in the Wikipedia, you can find other sources, you'll find something very similar. It says, field is a physical quantity. What is a quantity? Is that a physical object? Can you hold a quantity in your hand? No, you can hold the potato in your hand. You can hold a bag of potatoes. You might have 10 potatoes. That's a quantity of 10. You don't hold 10. What you hold is potatoes. These people are saying field is a quantity. Okay? And that's for the purposes of so-called physics, mathematical physics, that has value for each point in space-time. In other words, it's a concept. That's what field is. It's a concept, an abstract concept, and this is what they're going to wave. They're going to move it up and down, this concept. You know, they're going to move love. They're going to move information. They're going to move intelligence up and down. They're moving concepts around. And in mathematics, you know, they have a field is a set. Now, what is a set? Well, that's got to do with mathematics. And for those who took math, you'll know what I mean. It's just a collection. That's it, of whatever. And so that, again, a collection is not a physical object, okay? So that's the starting point for debunking the field notion. But here is, here's what they show. This is what they show for light, okay? You have two fields, the electric and magnetic field. What are you staring at? A bunch of vectors. If you look, those arrows, again, are not engine arrows. What those arrows point to are magnitude and direction. That's what they have. What is that? That's a number line. What you're seeing is a bunch of number lines that are flowing. They turn this into something physical or something that you can see so that you get fooled into believing that you're staring at something that is physical when it's not. What you're seeing is a bunch of concepts, okay? That's what that is. Okay, what's the next one? Does not explain the physical mechanism of wave interaction. See, is the photon a physical entity? Does it have size? Does it have mass? All this other stuff. And here you can see what I'm talking about. Okay, I try to illustrate this. And this is also using their stuff, okay? I'm not putting words in their mouth. What you're seeing is what they put. They say, we've got these waves. Okay, fine, we got the waves. What are those waves? Are those waves just a string? Is it a rope? Is it a wire? What are we looking at? And the question is, okay, whatever that is, how do they interact? They're not telling you how those two waves are physically interacting. They just say, look, if you add the number 1 plus number 2, you get number 3. That's all they're saying. And what you're seeing there is, again, amplitude and not anything related to light. You're not even seeing a standing wave, because the only reason that gives you the sensation of being a standing wave is that it's straight across. In other words, it's horizontal. Somehow it doesn't fall. Why doesn't the wave fall down? You know, and I showed that the other day. Let's see if I can get myself back up here. Showed that the other day. You know, here, if I don't hang on to this on the other end here, that's what we should be seeing. The wave should fall if nothing is supporting the wave, or if the wave is not attached at the other end. And these people do this artificially. They have this like a stick and going like that without anyone holding the other end. Why does that wave stay straight, more or less straight? You know, why does it flow horizontally without it falling? You know, especially when they claim also that gravity affects light. So we got a lot of problems there in their physical interpretations. Okay, let's see if I, here's the summary again. Let me get it up there. Okay, what's the next one? States that light does not encounter electron waves when it leaves the water or the prism. They have two videos, one for water and one for glass. And there are prisms made of glass, so prism is a valid word there as well. They don't do prism. Maybe I know why. I'll talk about that in a second here. But here you see what I showed a couple times ago. There is air all around a piece of glass or a prism or whatever. So you have the red waves there that are the electron waves, supposedly, which we cannot imagine. They have to illustrate them to tell us what they're really talking about. And then you have the waves of light that are going through the piece of glass. But the waves come from air, go through the glass, and then go back out into air. So they do encounter atoms, they do encounter electron waves also in air. And so the question is, they never explain why light, when it goes out of the prism, right? It does encounter atoms and electron waves as well. Why doesn't it slow down there? So they haven't explained the interaction between the air molecules and light. They have not explained that. Okay, they have to show that, and it'd be nice if they made a video of that so that we could see their mechanism, what they're proposing. Of course, they can't do that. They can't do that because their whole interpretation is nonsense. That's why they can't do it. Okay, and here we have their explanation. They say that the electric field of the atoms, in other words, the electrons of the atoms in the glass, slow down the light going through air. And all it is just a mathematical thing. There is no physical interpretation. What they do is just put a bunch of arrows there. They don't show the waves. They don't show the interaction between waves. What they just do is just say, look, there's an electric field that opposes the incoming light, the light that comes from the air into the glass. Okay, and they say, look, all these electrons, they move them around, okay? They say that they've got the electrons on the wrong side. That's fine. It doesn't matter because right now we don't know. Are they saying that all these atoms realign? And how do they form waves? And even if they do that, then what is the interaction between the light coming into the glass and the electron waves, the alleged electron wave that opposes that incoming wave front? Okay, so there is no physical interpretation. Not from these folks. And until they draw it, until they illustrate it, we don't have any idea what they're talking about. Let's see if there was something else I wanted to say about that. Yeah, here's another issue, and that's I brought this up that if light comes into a prism, it breaks into color, white light, right? When it goes out, if there is nothing to prevent it, like they say that there are no atoms or electrons or anything out there, like if they do this in outer space, well, then we should have white light coming back out again. Why do we still have colors? I mean, what you really get is not this. You get this other one. Give me a second here, see if we can get it up here. This is what you get, okay? When you do the experiment, you get something like that. You get colors coming out. And their prediction, to use that word, is this, that you should have white light coming back out because now light returns to its original speed that it had before it went into the prism. Okay, so they have a series of problems with their explanations, okay? And last but not least, we have that they confuse amplitude for speed. Now, I think that was the big one because that's what they were trying to prove with the video. And here's Bozo Lincoln again, who makes a lot of money, more money than he deserves. And I like to ridicule these guys. And this is what he's saying. And I want you to pay close attention to that red arrow on your right. If you look at the wave at the top is the electron wave. The red one and number 2 is the light wave. And the third one is the wave that it goes through the prism. In other words, it goes slower according to them because the blue electron wave slows the red light wave down somehow. They don't show the interaction. They just say it is so. Okay, and these are their words. The one that you read there on the bottom, it says, let's go here. When one wave is moving at a different speed than the other one, the result is a different wave. That's all they say. Okay, this is the entire mechanism. But one that has a different speed than either of the two. If we add the two top waves, mathematics, which have different speeds, the bottom wave also moves, but slower. And you can see that's not the case, because when you look at where the red arrow is now when it starts again, the two waves are moving at the same speed. Okay? What this guy is confusing is amplitude, which is the up and down, the height of the wave. All we're doing is making the wave go higher. So when you look at it closely, all he's doing is doing amplitude, and he calls this speed. He confuses amplitude with speed. And that's the mechanism that these so-called professionals, authority, right, are proposing for why light goes slower through a prism or through glass or through any denser medium than air, like water, for example. So you be the judge. You go and verify, run your own test, reach your own conclusions. If you like to swallow authority because you simply conclude that all these geniuses cannot be wrong, well, fine. I mean, I can't do anything about that. All I'm saying, all I can do is present my case, show you that these guys have no idea whatsoever what they're talking about. You do have people like Feynman, even Niels Bohr and Susskind, more modern today, all these people saying they don't understand their own theories. No one believes them. They say, no, of course you understand your theory. Otherwise we wouldn't have computers, we wouldn't have GPS. And that's what people have in their mind, ignorant people have in their minds. No, these people don't understand the theory. They will never understand their theory because they're using the wrong mediator, particles. You can't do physics with particles, discrete particles, because you can't get them to move in the first place. How do you move a discrete bead that forms the ether or that forms some kind of particle from quantum? How do you get it to move in the first place? Why does it move? The only way you're going to get it to move is if another one bumps into it. Why did that one move? And so again, they do it with bumps, one hitting the other one and hitting the other one. Where's this first bump coming from? From outside of space-time? Who's pushing the first particle? That's the issue. So you can talk about pressure, you can talk about a lot of nonsense, and what you need to do is explain what causes that pressure. Well, what is the origin of that? It's like trying to explain what causes motion to begin with. Good luck with that one. Anyways, if I'm not too sick, I guess I'll see you on Sunday. I'm losing a little bit of my voice. Maybe coming down with, hopefully, just a regular cold, maybe not the coronavirus, but we'll see you by Sunday. So we'll see you then. See you on Sunday. Bye-bye. Have a good day. Bye-bye.